So there are two types of feature encoding. One is label encoding and the other one is one-hot encoding. Now we can discuss their uses as well, where to use which type of label encoding, actually feature encoding. So let's first discuss label encoding and one-hot encoding, and then implement them, and finally we will discuss where to use which encoding scheme. So what is label encoding? This thing we have already discussed as an example. We assign some label to every categorical feature, right? We have already discussed it. So this is the same thing. The second thing is one-hot encoding. This is almost again the same thing, but with a little bit difference. So let's say we have Paris, right? So let's say we have 7 number of features in our record. So there will be 7 new columns, right? 1, 2, then 3, 4, 5, and so on. 7 new columns, right? Every column will be having a prefix as the value of row. So let's say first row is Paris, so Paris underscore city, okay, then DC underscore city, then London underscore city, and so on, and finally Lahore underscore city. Now wherever Paris is in, so it works in aspect of rows. So in which row there is Paris, will place 1 in the Paris column and will place 0 in all of the columns, right? And wherever there will be DC in the column, in the row, will place 0 in every row except DC's column, right? And so on and so on. Let's say we have Beijing in a row, so we'll place zeros in every column except the column where there will be Beijing. And finally there is Lahore, and same thing, we'll place 0 in every column, and finally we'll place 1 in the column of Lahore city. That's how we can do one-hot encoding. So we have discussed both types of encoding, label encoding and one-hot encoding. In next video we'll actually implement both of these types of encodings by using Python, and finally we'll also discuss which type of encoding should be used at what type of dataset. Okay, first of all, let's import the dataset by using pandas. So here is the dataset for kidney disease, and let's run it. So here's the dataset. So I have printed the head of dataset, which means the first 10 rows. So it has total 26 columns, which means it has 26 features. So it has different features like age, blood pressure, and many other features, red blood cell count, and blah blah blah. So in red blood cell count, you can see that there are some categorical features, some categorical values like normal. NaN means not a number, or you can say that empty value. It also has some values like abnormal, right? So let's set our target that we want to convert these red blood cell count features into from categorical features to numerical features. Okay, so and we want to do it by using label encoding first, and then later on we'll do it by using one-hot encoding. So there is a command that is called dtypes that is available in pandas. So what is df? Df is our data frame in which we have read our CSV file of kidney disease, and we'll say data frame or df dot dtypes. It will display all the data types of all the columns. So this red blood cell count, this is the column, or this is the feature that is our target. It has data type as object. Other than that, let's say age has a floating point data type. You can see that it has a floating point, and so our target is RBC. So in label encoding, this is how we can do it. So we'll say data frame df. Okay, df, remember df is a pandas instance. So data frame dot columns. In columns, wherever dtypes is equal to object, convert it to list, right? So it will display again, it is just displaying the list of those columns only that has non-numeric data types, or no, or you can say categorical data types. Okay, so then finally we'll import a label encoder from sklearn. So here you can do the same thing by using a label encoder from sklearn as well, but here we are doing it by using the built-in functions from of data frame, or you can say that of pandas. So we are replacing RBC or RBC column with what? With this thing. Now what is this thing? Here we are saying that RBC column, remember this is the old column, RBC dot as type category. So we are converting this object type into category type. This is necessary if we want to, you know, convert categorical features into numeric features. And then we are saying that dot cat, which means categorical, dot codes, which means we are saying that convert it into codes or numerical features. And let's run it, and here we are printing it, or we are saying that data frame dot head, and here you can see that this is the column RBC. It has -1, and 1. What is -1? -1 actually it is representing not a number value. So the invalid values are represented by -1. Other than that, it starts representing values from 0. So normal has a code what? It has a code 1, and abnormal will be having code 0 or something like that. So let's see how many distinct values RBC column has. Let's run it, and here you can see that it has 201 1 values, which means normal values, right? And -1 values, which means invalid values, are 152, and finally 0 values, which means abnormal values. This type of abnormal values are 47, right? So now our RBC column has been converted into our a numerical column. Now we can play around it by using our techniques that we have learned at PCA or whatever we want to implement over here. Now this was all about label encoding. Now what is one hot encoding? Again, the same thing. Let me print head first. Here you can see that now let's play around with these two columns, right? So remember our last lecture, what was one hot encoding? If you don't remember, then you can recall it. You can do it by using sklearn as well. sklearn has a one hot encoder module, but here again I'm comfortable with doing it with pandas. So here is something. Here is how we can do it. Again, pd.getDummies, it is a function in pandas. Here we'll pass data frame, then we'll pass the names of columns that we want to convert. So we want to convert two columns, let's say these two columns, PC and PCC. I don't know what they are because I'm not a medical expert. So, and also I'm saying that add a prefix to it. What do we mean by prefix? Remember, we have studied this in our lecture. This is a prefix. Here prefix here there is no prefix, there is a postfix that is called city _city. So you can also add a postfix as well here, but I am comfortable with adding some prefix. Prefix means these letters will come before the name of column. So let's say this PC column has two values, normal and abnormal. So it will make two more columns over here. First column will be PC underscore normal, and the second column will be PC underscore abnormal. Same thing will go out for PCC as well. So let me run it, and here you can see that PC abnormal and PC abnormal and PC normal. So wherever in which row it was the value of PC was abnormal, there is 1, and wherever the PC value was normal, there is 0 in this column, and same goes out for this column and this column and this column as well. So I hope you guys have got the concept. Let's again test it. So PC was normal in first row. Okay, so here you can see that PC normal is 1 in first row and 0. PC abnormal is 0 in first row, and you can tally it in your own notebooks. So this was the concept of feature encoding, and we have practically studied both of the feature encoding types in Python. In next lecture, I'll tell you where to use which technique. Okay, so finally we are discussing where you can use, you should use label encoding and where you should use one-hot encoding. It really depends upon the data set that you have. So some of the axioms or norms that data science community actually follows is the following. So let's say when you have a very large number of categorical features, right? So you should use label encoding. Why? Because if the number of categorical rows in one column are very large, and you will go for label encoding, then you'll obviously have to have that many number of columns as well. What do we mean by this? So let's say here we have only 7 rows, right? So there will be 7 more columns. What if we have 700 different values for this feature, right? Then what will happen if we will use one-hot encoding? We'll be having 700 different columns for this only one categorical feature. And what if you have many categorical features that have many distinct values? So if the number of distinct value is very large, then you should use label encoding, because no matter how many different features are there in the rows, it will obviously produce only one new column. So if the number of categorical features are very large, you should use label encoding. Otherwise, if the number of categorical features is not very large, you should use one-hot encoding. Now, what do we call large and what do we call not large? It just depends on you. You can say if you have less than 5 features, you should if you have less than 5 features, you should use one-hot encoding, and if you have greater than 5 features or greater than equal to 5 features, you should use label encoding. Again, this is just a rough estimate from my side. The second thing is you should use label encoding when the features are ordinals. So there is some order in the features. You can use label encoding, and if there is no order in the features, you can use one-hot encoding. So these are some practices that usually data science community follows, but since it is a data science thing, you can engineer your own technique as well.